The art of specifying natural stone. Just a little background on the intent of the course here. The MI has numerous courses to give, and we saw the popularity of 101, being what, 85%, 80% of the courses given. And so the idea here was, how do we sort of bridge the gap between a number of these different presentations and give in a format that's maybe not as intimidating or as technical to present, but yet is useful and is really practical for a designer who's trying to specify with stone. So that was the basis for coming up with this course, and hopefully we can achieve that through it. So this is my contact information in conjunction with the MIA, part of the CEU Continuing Ed program. Again, our speaker certification. This is important to make sure we've got our certification so that the audience understands that the MIA knows you're doing this and knows you're qualified to do so. Course numbers, I always make sure at this point, if I haven't already, first thing I bring up is sign in on the sheet. Make sure you give us your numbers, your IDCEC, CEC, AIA numbers, what have you, so that we can properly register for you. And then please fill out that evaluation form. Get that evaluation form out early. When I don't, it's a scramble at the end. So, very important. All right, so the basis of the course here, basically we're trying to give architects and designers an overview of how to specify natural stone properly. So everything from, we want to choose the right material for the right application. What do we need to know about that material, its color, its variation, how it's quarried, how can we finish it, and what factors are going to affect the price, as we go about designing this project, and then what resources are available to us and to the designer to help us achieve this goal. So our objectives here, the first one, we want to discuss the responsibilities and liabilities of each pillar in the typical construction project. Secondly, review resources to find more information about natural stone standards. Thirdly, learn how to plan for the longevity of an installation by specifying appropriate materials. And then finally, evaluate factors specific to the price of different materials, finishes, and methods. So we'll start with our first module, responsibilities and liabilities of each member in the construction process. So it should be very clear up front that each party has varying responsibilities throughout this process, and communication is absolutely critical, particularly in the early going on a project, so that we can all achieve the goals that we're after. So everybody is working ultimately for one goal. We want a product that satisfies the end user, and within that process, each of the different groups, while they have a common goal, sometimes we might have some competing interests within that. So it's important to understand how we all fit together in the process. So basically, the pillars we mentioned, the groups that are involved here, we have the specifier, who's the architect and the designer. And we'll go through the responsibilities of each one of these here in detail. We have the general contractor, as we know, who's overseeing all of the construction and coordination. We've got our material suppliers who are bringing the products to us, generally furnishing them to the installing contractor. And then, of course, we have the owner and the end user who's going to be using the building for its intended function. So we'll talk about how all these responsibilities are interlaced. First and foremost, we have our design professionals. The primary responsibility of the design professional is they've got to make the material selection. It's up to them ultimately to make a decision based on aesthetics, but also on performance criteria that are going to allow it to be a good and long-living project. And they need to do this through not only obtaining visual samples and making sure that aesthetically we've covered it, but also any sort of testing that might be required to back up that the product is appropriate. So if I'm going to hang travertine on an exterior wall in a cladding, mechanically anchored cladding format, I better make sure that as the architect I'm requiring in the specifications that ASTM C880, for example, is included, so that we are all getting that full information that we need. So that's it. They're going to put this thing in the plans and specs and send it out to the world to go to the GCs, and they send it out to their subcontractor world. We want to make sure that that spec has all the information in it that is going to be necessary to get a proper and responsive bid. Material suppliers. It's up to the material supplier to be able to obtain the material that meets or exceeds the parameters outlined in the specifications. And any related documents that are required, any specimens, any samples, and in most cases, in many cases, the testing data that's needed to substantiate it. Now, one thing I want to be clear on the testing, I think it's important that we understand that most suppliers can acquire some basic testing data. It's not realistic to expect that a supplier is going to have the full litany of the 6 or 7 key ASTM tests that you might want, you know, if it's a high-profile job. So often as the specifier, you want to be sure that if you're looking for the full litany of those ASTM tests, that you have that in the specification, so that the cost of them, which are exorbitant, or high, I should say, the cost is covered in the job. So if it's some basic stuff, what's my density, you know, what's some basic, I might have some basic flexural historical testing on it. That's not unreasonable to require of the supplier. Asking them that they've run the full litany, you know, of wet and dry samples, for example, through all of the 5 or 6 tests is something that it's got to be specified on a project-specific basis. The installing contractor, all right? The primary role of the contractor, of course, is that they're providing the skilled labor that can actually install this product in the manner that's been prescribed. And so it's up to that individual or company to acquire the proper labor, understand the setting methods and mechanisms that are available to them, and that they can in fact adhere to the project specification. And then the owner end user, they also have they play a critical role in the success of the project. They need to provide realistic information about the project requirements so that we understand what you're really truly trying to achieve. That's going to help the designer and the architects come up with the proper product and on down the line. They also have to understand that at some point the project is actually going to be complete, turned over, and then it's up to them to maintain the project. So their maintenance programs are critical to this entire process. So we got to understand what they intend to do from a maintenance perspective. They need to understand what's required of them from a maintenance perspective. And again, all that needs to get wrapped up early on in the design so that we're not putting the wrong product down. So that this will be a long-lasting and beautiful project. All right, so we've broken this class into these 5 modules. We'll be talking about the resources that are available in specifying a product. So if I'm an architect, there are certain resources out there I can go refer to, or if you're assisting an architect, there are resources you can refer to help in this process. And then as far as the products that we're specifying, we've got these 4 targets we want to try to hit. We want to make sure that that it's admirable, that the product is suitable, that it's available, and that it's affordable. And we'll go through each one of these here. Module 1 are resources. It's vital as we're going to specify material, stone products, that we are using the resources that are available to us. So in talking about resources, we'll talk first about standards organizations. So these are organizations that actually have generated standards that the industry needs to work to and meet. We use the ASTM test methods and specifications guides often and regularly in the stone industry. That's where all of our testing information comes from, be it our flexural Z880, our C97 density tests, our compressive tests, what have you. So they've set the parameters and the guidelines there on how those tests are to be performed on each and every material, and so we adhere to that and get our data from that, and we can make well-informed decisions from there. ANSI, standards and specifications within their organization as well. CEN is European standards, and the ICC, mandatory building codes adopted in the U.S. So this is basically, these are the standards. We've got to meet these things in order to be successful. I talked about the ASTM testing there, but basically these are the primary tests that we're going to utilize in selecting a material. So we need to understand the absorption and density of the product. So that's achieved through ASTM C97. And what does that help us understand? It's going to help us with our stain resistance. How much absorption does this material have, and is it going to be appropriate for use in a cold and wet environment? It's particularly important where we get into lots of freeze-thaw cycles. A place like Denver that runs, over 100 freeze-thaw cycles in a year. If I've got a highly absorptive material that's going to be subjected to those freeze-thaw cycles, I need to have that information. I need to understand whether it's going to be a problem. And there's freeze-thaw testing that go beyond this here, but the absorption and density gives us some indication initially. Compressive strength C170. This is important if I'm going to use if I'm stacking a wall as opposed to using mechanical anchors. How much compressive strength does the material actually have? Can I load it, and to what extent can I load each course moving up? That bottom course has got to withstand the weight from the very tip top. So it's important. It's also critical if I'm going to use stone as an exterior paving product. So if it's just pedestrian traffic, it's generally not going to be much of a concern. Our typical thicknesses are probably going to be just fine. But if we get out into vehicular areas where we're going to have lots of vehicles, we're going to have fire trucks, garbage trucks, what have you, we need to make sure we understand what the compressive strength is and that we've designed the thickness of that material and the setting mechanism and setting method in a suitable way so that we know that crush resistance is going to be there for us. C99, modulus of rupture, and C880 sort of giving us the same thing. Modulus of rupture is somewhat outdated at this point. It was based on testing brick. C880 is what I've always used in the past for determining flexural strength. It's a little more realistic. You actually test the thickness of the material you're going to use. So if it's cladding, it's really more relevant to what we're actually trying to do. Plus, it's not point loaded as the modulus of rupture is. We're actually using 2 points, so it more closely simulates the condition of a piece of stone being clipped top and bottom, and the wind resistance that it needs to withstand. So those are sort of the primary structural tests that we can do that give us a good idea that we're on the right path. And if one of these doesn't make sense, then we know we're not on the right path. The ASTM in the back of in the index of the DSDM has the minimums for each material type with these tests, and I refer to that often. It's a great resource. So if we've tested a material and the C880 isn't hitting the minimum recommendation that the MIA has thrown out there, then we need to look at a different material. Moving on, these are less structural and these are more performance-related ASTM tests here. The C241 is our abrasion resistance, and this is really going to tell us whether or not it's got any sort of ability to withstand scratching. I'm not going to put a marble or a limestone down on a large commercial project floor that isn't hitting our minimum requirements for the C241, because it's going to be a mess after just a few weeks of the mall being open. It'll be scratched and torn up. So that's important that we've done that homework. Also, in that same regard, the DCOF, or the dynamic coefficient of friction testing, is critical. It's a little bit in limbo with the stone industry right now. Hopefully over the next few months we'll be able to see an adoption of the new tile test that they're doing. I know there's a lot of work being done on that, but it's still something we have to consider, the slip resistance. We've got to meet the coefficient of friction so people aren't slipping. It's a liability issue, right? We have somebody slipping on a floor. We didn't do our homework. We didn't put a hone finish where we should have. It's important that we've done that homework. And then finally, we've got petrographic and mineralogical analysis, which we don't see very often. I've only utilized it once, and it was to solve a very particular problem, but that is available to us, where we can take that stone and slice it really thin and analyze it under a microscope and really come up with mineralogy of that material, and that helps us better understand whether it's going to be appropriate or not. Okay, so those are the industry standard organizations. Moving now into industry associations. There are a number of them, and they're all here to help support us in our efforts, both in design and in the application. So MIA, Marble Institute of America, is one, BSI is another, NTCA, TCNA, National Building Granite Quarry Associations. All these have been created and have guidelines that help us, the team, the pillar, achieve a successful project. We're going to get specific into the industry associations, but among the resources available to designers is the material supplier itself, or the quarry itself. Generally speaking, the quarry or the supplier is going to have access to the most comprehensive set of specs. They might have historical test data. They've got the anecdotal information. They've got the historical information on the performance of material. And so that's really that's a fantastic resource, is utilizing the supplier in that regard. It's important to note that some construction materials on the market, they're proprietary. So, you know, there's only a single manufacturer supplier, so understanding that's important. So you can utilize the correct resource in that regard. So getting more into some of the industry associations and what they offer designers and architects in aiding with their design. MIA, the primary publication is the Dimensional Stone Design Manual, which is the Bible, as I call it. It's really the sort of the leading industry standard out there for not only designing, but but basically trying to avoid issues down the road, and it's quite comprehensive. I reference it often. There are specific subject manuals and videos, safety, business management documents, etc. There are technical bulletins that will come out from time to time as issues come up or as new findings are revealed. There are iPad apps that are available. I have one on my iPad. I use it all the time. It's got all the latest publications. It's got the DSDM on it. There's, for example, the North American Stone app. There are certain quarries that are participating in that, and you can identify where those quarries are located. If you have, for example, a project that's lead driven and you need to find a quarry that's local and regional. And then you've got the MIA membership directory with accredited companies. So it's always a good resource. You can reach out to those companies. They're always more than willing to help in this process, because at the end of the day, as we said early on, the earlier we have people involved in the process, the more smoothly it's going to move forward. TCNA, it's got a fantastic handbook for ceramic, glass, and stone tile installation. I refer to this one often as well. It's respected as an industry consensus document. It's got very specific detailing. If you're not aware of that manual, it's something you should have. So it talks about, some of the nuances in dealing with stone tile as opposed to ceramic. And then if I don't know what the setting method is I want to use for a shower wall, for example, it has that detailed for us, and there's your detail to utilize in your drawings and specifications. NTCA is along the same lines. Again, they cover multiple aspects of tile installation, substrate preparation, all the way up through to grouting. And they have their NTCA reference manual as well. So it's I find having all of these available to me is very important and very useful. A great specific example of this is lighting. If I'm going to wall wash a wall that's clad in stone, well, none of these are going to tell you it's a great idea. And so it's just an example of where that specific topic is addressed, and these references are there to help us avoid the train wreck at the end of the tunnel. So also, if as most of us are involved in a green project, a LEED project, sustainability issues just in general, there's some great resources. We've got our course, the Natural Stone and Green Design CEU presentation. That's a nice resource on how stone fits into this. LEED 4.0, stone fits into a number of the material and resource requirements, indoor air quality, so on and so forth. And then there's the new standard, the NSC 373 Sustainability Standard, which is something, as that continues to grow legs over the next few years, that's something that you might consider, it's something that you include in your specifications, is using companies who are adhering to that standard. So great resources for green. The recap then for Module 1, and here's what I'll go through, and I'll ask these questions of the audience. and get their responses back, and hopefully they're able to answer those questions. And if not, if we can readdress whatever maybe got missed at that point in time. So that is Module 1. All right, Module 2, moving into the stone itself. We talked about we want the material selection to be admirable. And what I mean by that is we want, if something's admirable, it's something everybody can look at and be proud of. And that's really, that's one of the goals in how we're in selecting the proper material. Obviously, key in admirability is the aesthetics. All right, first and foremost, as an architect designer, we're looking at the aesthetics. We're designing beautiful spaces. And so it's vital in the early on initial selection, material selections in the project, that we are sticking to a few important steps. The first one is we want to make sure that we're working from current samples. I know every architectural firm has got a library, and in that library you've got a number of different materials from any number of suppliers. And it's important that we resist the temptation in the 11th hour to run to that shelf and grab I need a white marble, and I go grab something off the shelf that may be quite dated. Maybe it's 6, 7, 8 years old, and it isn't necessarily indicative of what's coming out of the quarry at this particular time. In worst case, maybe it's a product that's no longer being quarried. So it's important that we're working from current samples. And the way that we can ensure we're working with current samples is we want to partner early on with a knowledgeable firm or an individual who can help control this process early on, from that initial sampling to the final piece on the saw. And so I can't stress enough how important it is that you're using partners who understand this. And that could be, it could be the quarry directly, it could be a material supplier, it could be an individual consultant. That's really up to you and the budgets that you have available to you. So that's a vital thing. Also, in making it an admirable selection and project, we need to consider the range of the material. When we're talking about range, we're talking about the color and tone of the material. We're talking about variegation in the veining and in the different qualities and characteristics of the material. We're talking about, we might have a quartz vein, a dry vein, a mud vein running through the material. We might have inclusions, fossils, and then we have pits and fissures. All these things are a part of the stone. There isn't much we can do about that. It's innate. All we can try to do is we can try to control those to a certain extent. But the point of this slide is we want to be reasonable in that selection. Because if we try to control it too much, what we end up doing is we add unnecessary complexity and cost to the project. If we are trying to control it too tightly, the waste factor goes up. We're cutting through more material than is maybe necessary or is responsible, and it can add schedule. You know, the more the fabricator has to cut through, or the more block the quarry has to pull to get to that specific range, you know, the longer the lead time and the higher the cost. One thing to think about as well, depending on the nature of your project, the size, the scope, the scale, do we want to specify a range sample at the quarry or the factory, as opposed to just using range samples to approve our material? So the typical submittal process, of course, we all understand we're going to have to submit samples, and everybody's going to look at it, approve it, reject it, whatever that process, you know, becomes. But sometimes it's more conducive to go to the factory or to the quarry to actually view slabs, to view a mock-up, or whatever the case may be. This is generally for larger scale projects. It's something you're going to have write into the spec because they are expensive. But at the end of the day, that expense on a larger project is small in comparison to the challenges that can result if we're not getting what we want. So the range reviews are fantastic, but again, write them into the spec. Make sure you have identified who is responsible for which costs, and all in all, they're very good and very successful. if we are using range samples, we need to make sure that as a supplier, for example, I'm getting the full range that we can expect. And so that we don't have any surprises as we start uncrating finished material. So one thing we can help to if we're going to stick with the range sample process is we can get photos of current product, current slabs, current block to help us feel good that the quarry and the factory understand the requirements that we have there. Production photos are another a great resource to make sure that we're staying in line within the range we've all agreed to. We also want to make sure that we're specifying appropriate qualifications for installers and the appropriate installation methods. The MIA, for example, has accredited installers and fabricators now, and so that's a program that these companies have bought into. They have gone through the necessary steps to get accredited. The MIA has vetted them out and they have vouched for them, and you're getting quality installers and fabricators through those companies. That's something to consider so that we're not, in the scenario where, maybe we've got a tile guy bidding a bunch of exterior cladding who doesn't understand that system at all. So it's important that we're setting the proper expectation, and that's driven through the specifications. CTF, the ceramic tile industry, has their accreditations as well, and NTCA 5-star. And the care and maintenance objectives as well, it's important that that's spelled out, early on in the specifications as well, so that it is in fact admirable. We also want to make sure we're planning for performance. We need to consider the longevity of the material that we're using. Is it going to stand up over time? Is this a 100-year building? Is it a 50-year building? Is it a mall? Is it a train station? Whatever it may be, we need to understand the longevity requirements. If it's a cladding application, we got to make sure it's something that's going to hold up over time. Stain resistance, slip resistance, durability of the finish, all important in making this decision. And again, these tie back to our tools, our ASTM test data that are going to help us understand these. And we got to look at the sealers, the sealants, and the accessories as well that we're using to install these products. Are they suitable? Are they up to snuff? Do we have buy-in from those manufacturers that we're using the right products? Are we interested in, I think most of us are, but is it a city spec where they are actually requiring that it's designed to lead standards? And if so, are we keeping that in mind? So there's a sustainability goal for the job. We need to make sure we're falling in line with that. So if it's a local regional project, we want to make sure that we're finding material within that 500-mile radius that's going to be appropriate, not just close, but appropriate. Just because it's within the radius doesn't mean it's the right product. We want to make sure it's the appropriate product. Material use and yield is an important consideration. It's not really in the spirit of sustainability if, for example, we got a really tight range and we're blowing the waste up at the quarry. We're going to 60–70% waste. That isn't really in line with sustainability. Do we have the opportunity to use any reclaimed material? We've seen that in the past where we've been able to take some cladding, for example, from the exterior of a building that was being renovated and then reuse it as a toilet partition or as a countertop or something else on the project. And then important in all these sustainability objectives is the long life cycle. And that's a great thing with stone is you're going to get a long life cycle as compared to most of the other building products. So that's a good thing with stone. We're already doing well with that one just by the nature of the product. So Module 2, admirability. So we'll go through these questions here again, making sure that the audience is following along and understanding what we're after here. Okay, now let's talk about the suitability here in Module 2. If you've had Stone 101, you have seen this chart. This is sort of the classic classification of stones and formation of stones, and I like to show this again just to reiterate and reemphasize that these traits, its makeup, calcareous or siliceous, and its formation are critical in how we're going to use the material. So this is really the starting point. If we know we want a limestone, well, automatically we know it's calcareous and we know it's sedimentary, so we need to make sure that we're using it in a format that isn't going to cause us issues down the road. We know that calcareous, the calcium carbonate in those products or in those natural materials are going to react to acids or certain things. So right off the bat we know, well, maybe that's not the right material for what we're trying to do here in a water fountain outside. Maybe we need to look down at the opposite corner of this matrix and go straight to our granites or our basalts. So really great starting point in choosing material. As we're considering how we're going to use it, I mean, there's obviously a lot of different ways to use the stone outside: cladding, veneer, hardscape, landscapes, monuments, water features, pools, right? And each one of these is going to have a different requirement for the particular material we're going to use. Interior, very similar. We might see a little more use of spas, showers, which are going to, in wet areas in general, are going to raise a few more questions that we need to make sure we're going through. So, running through these, is it suitable? There's a number of things we need to consider. If for example, we're going outside with the product, we're going to hang it on a building, it's got to be resistant to weathering and decay. So rain, snow, and hail all have an effect on the material. Freeze-thaw cycles, how many cycles is this material going to be subjected to? And is it porous enough that it's going to become an issue? Are high temperature variations, is that going to have an impact on this particular material? And pollutants, keeping in mind we got, with the machines we use every day, we got carbon monoxide, sulfates, acid rains. If it's a cold environment, we have de-icing salts. How is that going to affect the material? So it's important that we understand the chemistry of those materials and how these things are going to affect that. Often historical, anecdotal information is the best when it comes to this sort of thing. I'm going to use a material that I know has been successfully used in a like environment. Talk a little bit about traffic volume for using it on the ground or in the flooring application. It's important that we understand that there is an abrasive hardness required. And so I'm not going to use a marble that only tests out in the hardness with the abrasive hardness of 6.0 in a mall. It's just not appropriate. It's too soft. So really that's what the abrasive hardness is a measurement of, how hard is this material. And so we've got the minimums here that we need to make sure we're understanding as we select that product. So if it's just in the entryway of a residence, I can be down at a minimum of 6, and that's going to leave me with a wide range of materials I can select from. But if I'm going to be moderate traffic, where we have residential entries or small commercial, we need to bump that to a 7. If it's heavy traffic, airports, mall floors, things like that, we really need to be up above a 10. And that's an example of where we've got, heavy commercial, we got 50 or more people per minute traveling across the surface here. So in that environment, maybe I love Durastone, Durabeige, really dense stuff, but 3/8 in a heavy traffic may not be appropriate. We got to make sure we're 2-3 cm on that as a minimum, because down the road it's got to stand up. We're not, we talk about life cycle. The material itself, it contributes to that, but the design also does. So appropriate thickness will increase that life cycle. And all that's, these are all great topics that are covered in the MIA's DSDM. So it's a great reference that way. A couple of other areas we need to think about in terms of the abrasive hardness. If we're in high volume areas, at stairways, elevator lobbies, where there's a high concentration of traffic, we need to look at an HA minimum of 12. Exterior paving, 12. So just making sure we understand those requirements and minimums so that we're not getting ourselves in trouble. All right. Kind of going through each of the species here real quick on what is or what isn't appropriate. Generally speaking, with the siliceous stones or granites, you can just about use a granite anywhere by and large. I mean, there's some with a lot of movement in them that may or may not be as appropriate. Some of these granites are coming with resin mesh on the back of them from the factories. It just helps their process. Well, that's something we got to keep in mind, is if that's going to be the case for that particular granite, maybe it's not the best lobby flooring material, because I don't want to have to deal with that resin mesh. Basalts, generally well suited for most applications, in or out. Same thing with sandstones. Some exceptions. We got to look at sandstone in a different light if we're going to try to mechanically anchor it. Do we need to do a dowel system instead of a kerf system? Again, ASTM testing is going to help us understand that. That might be a great time to do a curve test to see if we're within our allowable tolerances there. Slates, quartzite, serpentine, soapstones. We've got to be careful using those outside. We just have to make sure we're doing our homework. Some are going to be much more susceptible to those freeze thaw. They're not going to hold up. Generally inside, most of those products are going to be good. Again, how much foot traffic, and have we done the testing on those to make sure we're picking the right product. For our countertops, siliceous stone countertops, quartzites and soapstones, they're really quite good for our countertop applications. And of course, granite. We know that those are going to be suitable for that countertop environment as well. Moving into the calcareous stones, limestones and travertines. Are we going to use them outside? Well, there's certain varieties of limestones and travertines, depending on the application, that are going to be appropriate. If I'm going on the ground outside, I probably am just going to shy away from either one of those as much as I can. And if I'm insistent on using it, it's been done, but it's limited. The number of materials that are appropriate are limited, and we have to make sure we're going through this proper selection process, so that we're not putting a medium to low density limestone down in a horizontal application outside. They won't hold up. Interior, again, it's doing the homework. Most of these are going to be fine, but am I going to put Indiana limestone on a lobby floor? Probably not. Just isn't quite as hard as we would like it to be. Will it hold up? Yes. Are you going to have wear marks in it after time? Yes. And is that what you want as an end user? Probably not. So, and then again, countertops. If we're going to use calcareous stones and countertops, we got to set that expectation early on. It might be fine for a vanity. It might be fine for a transaction top. It might be fine for, the valet, but it may not be ideal at the bar, because we just know it's going to be etched inevitably. So, all right, marbles. Exterior use, we've got to be very, very, very careful. There really aren't very many that I would say I'm comfortable with. Again, let's get with the quarry, let's get with the suppliers, and make sure that if we think we're going to use it, that we're using the right one. All in all, my general rule: marble, keep it inside. And most of them are going to be good for vertical or horizontal applications. I think the key with the marble is we got to ask ourselves, is it an A, B, C, or D in soundness? And if it's the C's and D's and the factory is requiring the resident mesh reinforcing on the back, let's make sure we've asked that question early on, so that none of us are surprised after the bid when we find out that the installer didn't have epoxy thinset in his number, and then we're battling that. So it's just important to know what the classification of the marble is, so that we are prepared and we're specifying the appropriate setting method. Again, same thing with the marble countertops. Just depends on the application. We just got to really be careful in food prep areas, and if we are going to use a calcareous stone, be it granite be it limestone or marble, in a countertop, where it's going to be, in a food prep area, we're going to make sure we hone that, or at least recommend that you hone it, because at least that helps to conceal the appearance of etching, which is inevitable. Color. Is it appropriate in terms of its color? Some light colored materials will show more dirt. They might stain more easily. So a lighter colored limestone in a heavily polluted city, it's going to get dirty. There's no question about it. Even in not heavily, it's right on the traffic road. You're just going to have that pollutants are going to show up on there. Some light colored materials are subject to staining from setting materials and sealants. So we're going to make sure we're using white thinset on these light colored materials, so we don't have any of that staining coming through the backside. And it's generally a good rule to perform stain testing on all these materials. We always suggest, even if it's a cladding system and you're caulking the joints, we want to have that testing done to make sure that the caulking isn't staining the material. So doing our homework early on. Another thing to consider is if we're doing this in pool areas, exterior, what's the albedo and the heat resistance of the material? A granite on a pool deck is going to get really hot. Whereas if we get a light colored limestone or a light colored travertine that we've done all the other homework on and know it's appropriate for this use, those aren't going to be they're not going to retain as much heat. So the bare feet aren't going to suffer as much. So again, it's function over fashion, as they say in this particular case. The finish, is it suitable? All right. Vertical work, there's not many limitations. You know, we can pretty much put whatever type of finish on there we want. Polish may lose its luster over time. Heavy textures, you know, they're going to collect a little more dirt. It might be a little bit more difficult to maintain, but again, that comes down to the maintenance process. Have we picked the right material, and is our maintenance program that we've put in place appropriate? Horizontal work, basically our exterior use is limit to texture finish. We're using textured finish in an exterior application to maximize our slip resistance. So be it thermal, sandblasted, bush hammered, some of the more interesting hand finishes, fine adds, some of those things. That's the primary intent, is we don't want people slipping. We want to avoid that liability. At the same time, we don't want it to be too aggressive, because then we're causing a tripping hazard. So there's a little bit of a dance there, but good to get the samples early on in the finish you're hoping to utilize, and that way we can say we've done our homework. Interior, really, you know, polished or honed is going to be best, going back to the trip hazards. You know, flaming, bush hammering, it may be a little too much interior. We have to make sure, though, if we're using these smoother finishes, that we have some idea of what that slip resistance is. Honed, most of the time, is going to give you a higher resistance than will a polished finish. So it's better, in my opinion, to put a honed finish down. Plus, you're going to eventually wear tracks into a polished finish anyways. So hone it, you're helping your slip resistance, and over time you're keeping that finish as consistent as you can. Textured finishes inside on the floor, we got to be cognizant of. They do create something of a maintenance issue. As we put those textured finishes on, you've got the peaks and valleys, you've opened up some pores, so there's a lot more areas for dirt, dirty mop water, foot traffic, what have you. The dirt will collect in those, and it will tend to show, and it's more of a task to maintain those. And in a light colored stone, there's a point where no matter how much you clean it, it's there, it's deep in the pores. So, all right, so those are the finishes. We'll talk a little bit about suitable substrates, setting materials, and accessories. We got to think about our backup systems. Make sure that we're doing our homework on that. Stainless steel, extruded aluminum. We want to use non-staining, non-corrosive materials if we're mechanically anchored stone. Copper wire, not appropriate exterior. If we do use it, make sure we're doing our homework on that. This is where your engineering, your qualified installers come in, where they can design a system that's appropriate for what you're trying to achieve and get the engineering calculations on the back end to justify it. Structural layers, you know, stone we might need 2, or ceramic only requires 1. Setting beds, are we getting our adequate compressive and structural strength? Are we taking the deflection into mind? If we designed our stair treads so that we get that L over 720 minimum that we require, you know, in stone? Are we getting appropriate drainage so we don't have water standing on the stone, which is not good for liability purposes, but also we don't need the effect that water has just standing on stone over time. Always considering our expansion and control joints. I know we don't like to see them because they tend to break up the patterns, but if you don't employ those properly, you're going to have cracking. And then thinking of code requirements based on the application. So if we're going to use an adhered veneer, for example, we've got an allowable height that we have to make sure we're staying under, and then maximum piece size. You know, there's basically the 15 pounds a square foot maximum size of 720 square inches. So making sure we understand that, so we're not designing beyond what is code driven. Sealants, seals, flashings, gaskets, making sure all these things are suitable. We've done our homework. that we've got the right sealer. If it's a lead issue, we want to make sure that the indoor air quality is appropriate. We're using a water-based sealer as opposed to a silicone-based. Important to remember with sealers, they don't make things waterproof or stain-proof. It makes them water-resistant and stain-resistant. So just an important distinction. So we don't expect more than what they are intended to achieve for us. So module 3 recap. Again, go through these questions here, and that will allow us to move on to the next module 4, which is the product available? We want to consider availability. So it's important as we're selecting a material that we're asking of the supplier or the quarry, whichever we're working with, that, well, can you actually produce this material in the sizes and the finishes we need within the time frame that we're going to need it? And I've run into this in the past where maybe not. It might be a great material, it might be real close to the job and meet our lead requirements, but it's going to take them 4 times as long to quarry and fabricate and ship it as we actually need for our project. So it's important that we're asking those questions. Can it produce adequate yield? Is there enough of it? Is it a winter quarry? And if so, do they shut it down? Usually they do. Does that mean have they set aside appropriate reserves so that they can continue fabricating throughout the winter? Or is it a factory where they don't have the ability to fabricate through the winter? So all things that are important to realize as we design with this stuff. We're always on the critical path as the stone suppliers or installers, so these things really affect it. There's also maybe some recent impacts from Mother Nature. You know, we had earthquakes in China that affected certain quarries. Last year, the flooding in Carrara put everybody behind. They simply couldn't do their work. And then there's the ever exciting holiday and maintenance shutdown. So Italy's they're shut down now. It's August, so they go away for a little while, and then there's always a mad rush and dash before that shutdown. They're trying to get as much out as they can, and then there's trying to get it all ramped up again. So cutting around those times is important to realize. China and their New Year, early in the year, has the same impact. So making sure that we are aware of that, and if it has to be fabricated during that window, maybe we need to select a different product. Any risk of the quarry running dry? We saw that happen on a St. Maximin limestone quarry in France. Beautiful stuff, but the last job that the company I worked for at the time did, well, that was the last job anybody was going to do because they ran out of it. We do run into sometimes to government closing quarries, Indian Kashmir. There was a number of them that they found some improprieties there with the quarries, and they shut them down, and they're still not open. Chinese Moon of Pearl is another one. The government over there has controlled the production of the quarry, limiting it, stopping it altogether, or what have you. So things we don't necessarily think of when we think about all the other things with stone, but they're critical. In our selection of the material, have we selected the grade and the range, again, that's appropriate? If I really love cream of marfil ivory, boy, it's beautiful, but if it's a big job, it takes forever to find that selection. Tundra gray is another example. It shifts from taupe gray to beige, or to blue. Are we getting the right selection? Is there enough of that selection? Some of the wood veins, again, we're really trying to control that, the range on it, and some things are just innate. We can't control them. So is it available in the finish or in the range that we want, and can we loosen those requirements enough to make it work for the project? Again, limited sizes. Can I get the product in the blocks big enough to do what I'm trying to achieve with it? It may or may not be. Basalt in and of itself, it's limited as it comes out of the earth, so I can't do large format pavers with that. Are the modules restrictive? All right, standard versus custom tile modules. We could consider that. Can we work with a 12 by 12, or do we need to really work with a nominal 11 7/8 by 11 7/8 to account for the grout joint? It's important to know that early on and make sure we're clear on that, because it affects cost and it can affect lead time. Is the material in high demand? Calcutta gold's a great example. I mean, stuff's just flying off the mountain there, which makes it challenging for a job that's a year out. If I'm giving you samples of a Calcutta gold, for example, or the quarry, they can't really guarantee that for a year from now when you actually start having them quarry for the job. So market demand definitely plays in. Great example of where a range review might make a lot more sense than trying to sample. Does the supplier have consistent and reliable access to the material? We talked about the winter quarries, block yards. We're seeing a lot nowadays, especially with China. They're cutting stone that originates from a different country altogether. And so if we're going to go that route, do they have access to enough of that material in the range that we want? And it's important that we're understanding that so we don't get ourselves in trouble. Is the factory big enough to produce the volume we need to meet the fabrication schedule? And then beyond that, can they cut and pack in the sequence we need? So if we're doing cut-to-size countertops on a 30-story building, I can't do all the A's. The A unit on the 30th floor, it being there on the job first, does me no good. So we need to make sure that they have the ability to cut it in the sequence that we need. Is the supplier specifically qualified to do the work? Another great question. There are fabricators out there who are specifically working on tile. That is their bread and butter, cut and tile. Brazil is a great example where they are predominantly focused on granite slabs. And they don't really want to change their systems to do cut-to-size work. So if I'm going to use a Brazilian granite for a large cut-to-size countertop project, I better make sure that it's available to me out of China so that we can make sure we're getting it. Can they do cubic work? You know, can they do copings and cornices and hooked corners and those sort of things if we're doing a more classic and bulky application? Not all of them have that ability. And then are they appropriate for the type of material that it is? They might tell you they can work with granite or marble, but they're really more suited for granite. So we got to be careful that they're well-versed in the medium that we're trying to work with. So there's our recap for Module 4. We'll run through that. Module 5, Affordable. Affordability, we put this in here because it's really critical. I can't tell you how many times my heart was broken because a big job, they VE'd the stone for aluminum panels instead of stone cladding. And so it's important early on that architects and designers, you've got a vision and you've sold that vision to your client, and it's critical that we control that value engineering process from day one rather than going through all this work, designing what we want and love, and then seeing it get cut out of the job at the end. So we want to try to do that work early on, so we've already VE'd, so to speak. So we got to consider the source in terms of affordability. The yield of the quarry. Is it a material with a lot of waste? Well, that's going to drive up our cost. What type of technology does the quarry have to efficiently extract the stone? If they're not up to snuff, they're not going to be able to pull the block out quickly enough. So you got a potential schedule issue there. And that just extends the cost to everybody. Is the quarry easy to access? Or do I have to go, planes, trains, and automobiles to get the product to where I need it? Is the quarry close to the processing factory? So there's that shipping time and that shipping cost. If I've got to take block and ship it all the way across Europe to get it to the factory that I want to cut it, as an example, well, that's just added cost we're adding to the project. And then how easy is it to get to the port? Am I cutting it in the middle of a country where it has to get on a barge and float all the way down to the barge to the port, and then to the port, and then on out on the ocean to the destination port? So all those factors start to add to the cost. We can also think about our environmental responsibility, not just cost in terms of dollars, but cost in terms of the environment. And sometimes for these quarries to be environmentally responsible, there's a high cost for them to do that. But are we using a factory where their waste materials can be utilized? They can be utilized as a byproduct. They can be used for road fill, road base. They can, limestone can be used for aggregate, fertilizer, what have you. If they have a means of using their waste where they can recoup some of that cost, then the overall cost of the material will go down accordingly. Labor and logistics. Is the stone difficult to process? If it's granite and I'm carving it, boy, it's a lot longer than it is to carve limestone. I'm going to burn up a whole lot more blades, so there's more expense there. Thickness of the finished product, that's going to affect the material required and the shipping costs. If I can use a 2 cm thickness for a countertop or a veneer, why not? Instead of 3 cm, provided we've done our homework and provided it meets the the other structural and durability requirements that we need. But we can drive the cost down with the thinner product. Complex products, mosaics, things like that are much more labor intensive, so your cost is going to be higher on a unit basis for those. And then sometimes unique finishes can be more labor intensive and may affect the material thickness as well. So take those factors in mind early on so we can, if we want texture, we can get the texture. We've already done our homework and we've selected a material that's appropriate, and we can apply the finish we want on it without having to sacrifice down the road with getting VE'd. Manufacturing efficiency, 60 to 7% yield in fabricating stone slabs. So there's already waste embedded there, but how do we minimize that? 12 by 12 tile has less waste than large format tile. So again, what's the sweet spot? What's the optimum module that's going to help keep that waste down, and it's going to help us to save as much expense as we can. Affordability for the end user down the road, care and maintenance. If I don't want any care and maintenance, travertine may not be the right thing for me. Maybe a limestone floor isn't correct. I need to use something that I know is a little denser and harder. And then keeping in mind supply and demand. So if we go back to the Calcutta example, we know that they're hot, the price goes up, right? Basic economics. So if we can live with a material that isn't in such high demand, we're going to automatically be able to save money off the top right there. So recap, what factors affect the price of stone? So we can go through that summary of that discussion right there.